then Ni, so Al gets
Right.
oxidized.
So, I wish I could make this a little bit bigger. It looks really small. That's not so bad. All right. So, yeah, if you go to table J, this is really important. Okay, if you look at one of these, you get one of these on the Regents, I hope you think Voltaic cell. It might tell you it's a Voltaic cell. So the first thing you should always do is go to table J, look up AL, and then this is Ni, obviously it's chopped off, and then AL is going to be higher. What does that mean? Oxidized. So then you say, okay, anox, red cat. So this is oxidized, right? So this is my anode, and this is oxidized. This is my cathode over here, and that is reduced. And remember, the cathode is this bar. It's an actual piece of metal, like the terminals on a car battery, those two on top that you hook up the jumper cables to, they're solid pieces of metal that go down into the battery. Same thing here, right? So this is your anode, that's your cathode. The electrons would go up the wire, down, and then into the Ni. So from Al to Ni, good job, Grant. Who remembers what happens to this over time? It breaks down because it's getting rid of all those electrons. If you get rid of enough electrons, it'll start to decompose and deteriorate. What happens over here? Gets bigger, right? That was the Garfield thing. Fat cat. Cathode eats up all those electrons and gets bigger and bigger. So the cathode gets bigger. When I show you the Voltaic cell today, I'll show you the anode and cathode. I masked them in period 2. The zinc is 3.2 and the copper is 4.4. And then what I'll do is I'll hook it up today and leave it tomorrow and all weekend. We come in Monday and I'll take it apart and I'll remask them. The zinc should decrease because that's our anode, and the copper should increase because that's the cathode. All right, I do that every year, and usually it does increase just a little, but there is a small decrease and increase. So you'll see that it actually works. All right, so that was 72. 73, all right. So reduction or oxidation, what are they asking for? Oxidation. All right, so if this is aluminum, and what happens is when it loses an electron, it breaks off and turns into Al plus 3. That's what's actually happening. The metal is getting rid of electrons and turning into a cation. So the answer should be Al0 yields Al plus 3 electrons. That's the answer. You could also put, if you use the equation underneath it, you could also use the balanced equation. 2Al0 yields 2Al plus 3 plus 6 electrons, because that's positive 6, negative 6. Either one. You could do either one for that answer for number 70. What is that? 73. Questions at 72, 73. Okay. 74. All right. This is not a redox question. This is a stoichiometry question. All right. I'm just going to move this up so we can see it. All right. So we have a 2 to 3 mole ratio, right? So really it's 2 to 3 equals x over 9. This is how I would solve this question, because it says how many moles of aluminum if we have 9 moles of Ni plus 2. The 2 and the 3 come from the balanced equation. This is how I taught stoichiometry. Once you have your balanced equation, that mole ratio must be maintained. So if you add more nickel, then you have to add more aluminum. How much? It's a proportion. It's a 2 to 3 ratio. So 2 to 3 is the same as x to 9. X is 6 moles. Okay, that's the answer to number 74. The Regents loves to cross, mix, whatever word you want to use, topics. So they'll give you a Voltaic cell. So your mind goes to that, I hope. You're thinking oxidation, reduction, table J, you're thinking electrons, and then they throw this one in there, and it's a little confusing. I get it, because it's kind of a different question, but that will happen. They're not going to give you, 4 questions on all the same exact thing. They're going to kind of throw something else from a different topic in there, like this. All right, 75. In terms of energy, why is this Voltaic? Luke, what do you got?
Energy is transferred from an anode to the cathode.
All right. Give me another word besides energy. I know it says in terms of energy. I'll get to that. So energy really isn't transferred from the anode to cathode, but something else. The electrons, right. So I don't know if I could give that to you, honestly. Let's see. Maybe. I'd have to commiserate with the other teachers if we were grading that.
But you can't give him energy transfer from the anode to cathode.
Right, I'm not sure that that would count because that's not what the answer is. But he's on the right track.
But it says in terms of energy.
It does say in terms of energy. Energy isn't being transferred. Electrons are. Electrons isn't energy. It's an electron.
So in terms of energy, electrons.
So
From one half cell.
that's electrons. So from this side to this side, there's no energy being transferred. Okay, you know what? Yeah, I could give that to you. Here's why I could give that to him. Because what's this thing measuring? Volts. What's volts? What's that measuring? Electricity, which is a form of energy. So I could give it to you. So I'll give you the answer that I know the Regents is looking for. What they want you to say for 75 is the Voltaic cell produces electrical energy, which is kind of what you said. All right, so he is correct because from the left here, anode to cathode, as electrons move, that's creating electricity, which is energy. So yeah, you're fine. I'm glad we talked that one out. So yeah, what they really wanted you to write is the Voltaic cell produces electricity. That's what I wanted. Voltaic cell produces electricity. Why is that confusing to students? Because electricity isn't the same as energy as the word, right? The word is different, but energy and electricity is energy. So to make it clear again, in case I'm confusing, a Voltaic cell produces electricity. That is in terms of energy. So, or you could say it produces energy. That works too. Okay, no back. Go to this side right here. Yeah, this one. All right. So, oh yeah, I didn't give you the equation. Here, I'm gonna write it down. You write it down and balance. I'll give you a minute to do that or so. Here we go. So it's Al plus Cu plus 2 yields Al plus 3 plus Cu. So there's your equation that they would give you in the answer booklet. Go ahead, take a minute and balance it. Anyone already do this? How'd you figure it out?
I just kind of went off what all the other equations that have been under.
You did that exact thing?
Yep.
Good.
Get that down.
What's up, D? Ready to go over this? 20 seconds. I actually wish I had a timer, like a shot clock, built right into the board that I could just. That would be cool, wouldn't it? I think that'd be cool.
Hey, you should predict what the mass will be.
I will. I'll think about it.
I'm gonna say 5.2 and 2.
All right. Who already did this here? Someone in this row. Someone besides Curve. Someone else said it. Jojo, did you do it already? All right. Who wants to give me the answer?
I'll do
Ben
it.
King does. I can tell by the look on his face.
Put a 0 for the AL, and then 3 CU, and then 2 AL.
Very good. That's +6 and +6. Good. Not done yet. The charge is balanced, but now the mass is not. Like the number of atoms.
Oh. 2,
Yep. 2Al. 2Al.
and then 3 CU.
Very good. Good job. You did the hard part. The hard part was the charge. Good job. All right, so that's your balanced equation. All right, so really what's happening is Al is being oxidized, giving this 6 electrons, and Cu plus 2 is being reduced. All right, back up to this now. All right. Okay, so let's look at. Good enough. 61 or 62. All right, Al decreases. In terms of particles, Caitlin Hall, why?
The particles are leaving Al and transferring to C.
What's leaving, sorry? The particles. Good enough. Yeah, if you wrote the particles are leaving aluminum and going to Cu, you get full credit. You could be more specific. What's leaving? Electrons. So you could say the Al's losing electrons. That's why it's decreasing in mass.
But if it says in terms of particles, how can we use electrons?
Because an electron is a particle. So, yeah, no, it's good. I like where everyone's head is at. He said energy in his answer. You said particles because it said use the term particle and energy. Yes, do that. Use the terms they want you to. That's beautiful. It's great. Just understand there's other ways to answer it as long as, like Herf asked, well, what about when it says particle? An electron is a particle. Electricity is energy. So, however you want to answer them, whatever makes sense to you, use their terms, and we're good. So it's good you guys are doing it. I like that. 63. Cody, Saltbridge, what does it do?
63. Hold on.
Just tell me what Saltbridge does.
What it does, it
Mhm.
allows ions to migrate from one source.
Yes, it allows ions to migrate. Good job. All right. Now, on this side, I gotta zoom back out. Okay, here we go. All right. Oxidation for each element in cryolite. Here's cryolite. Na3, AlF6. Chi-Chi, enlighten the class. What the heck is an oxidation state?
It's a charge.
It's a charge. That's all it is. So Na is +1, Al is +3, F is -1. You go to your periodic table, look those up in the top right corner. That's all they wanted you to do. All right. I think more students were confused about that than I originally thought because the word oxidation, they start thinking losing electrons. I get it. It makes sense. But oxidation state is the same as a charge or an ion. It's the same thing. Ballast half reaction. Now, if they give you the two symbols, I think that's a lot easier than if they were to just say, write the ballast half equation for the reduction of Al +3, and they didn't give you Al, it would be harder. So you know 3 electrons are being gained, I hope. So Al +3 gains 3, turns into Al0. That's the answer to 79. That's the answer to 79. Questions on those two? 80. Deanna, you remember? Remember why?
Because it has electrons.
Close, not electrons. Another word starts with an I. Second letter is an O.
Ion.
Very good, yes. Molten cryolite. So this here, Na3AlF6, if you melt it, the ions become mobile. They can move. The answer is ions are free to move. That's the answer. How many words is that? 4. Ions are free to move. So that's all you need to write. Ions are free to move, or they have mobile ions. 3 things can conduct as liquids or in solution. Ionic is one of them, because the ions move. What's the other 2? We just learned about it. Acids and bases. They have ions. H+, OH-, so they conduct as well. All right, 81. We just started talking about this yesterday, so if you were confused, I don't blame you. Tristan's going to tell us the answer, though. What's the difference between a voltaic cell? Here you go, Tristan. I'm going to help you out. So, where is it? Here it is. So, here's a voltaic cell, Tristan. And there is an electrolytic cell. So tell me one difference. Use both of them in your answer, please.
An electrolytic cell requires energy from a voltaic cell.
Very good. All right, so an electrolytic requires, so this battery is basically a voltaic cell. So electrolytic requires power from a voltaic. I think I could give that to you. But what else could you say? So what does a voltaic cell do?
Produces energy.
Yeah. So the best answer is the voltaic cell produces energy, whereas that's this. And the electrolytic, this one, needs energy. Right? That was the answer to 81. All right.
Say how it's spontaneous.
All right, good. Yes, you could say electrolytic is non-spontaneous and voltaic is spontaneous. You could do that too. Good job. All right, take your notes out. Let's bang this out here quick, and then
Did you look up what that means?
no.
Yeah, but
I'm a busy man. I got things to do, you know.
Did you notice that was new? Yeah, did you notice
That's
that was
new too.
Yep. Yeah.
how long does it take you to put these together?
Like 5 seconds. Literally takes me 10 seconds.
Because Amit tried to translate the one yesterday, and he said his phone, he had trouble doing it. He couldn't find direct translation. He said yesterday was something about groups or packs coming to get me.
Yes. Yeah.
Okay, like wolves, like a pack of wolves, a pack of people,
Pack of people.
pack of people.
Vietnam people.
Vietnam,
And you
Vietnamese people
travel
are coming to
over-
get me. That's weird. All right, copy that in your notes, please.
Yeah.
Electrolytic cell. Electrolytic cell. Copy that down. Copy literally everything you see. Okay, you don't have to write the word inert electrode. All that means is these metal bars aren't reacting with the water. They're doing what they're supposed to do for the cell. They're not doing anything else. They're not reacting any other way. So label this one the anode, label this one the cathode, a little positive here, negative there. All of it. The charges, the half reactions, the battery.
Draw the pole.
Draw it.
Oh.
Yeah. It doesn't have to be as detailed and as nice and neat.
Oh my god.
All right. Just sketch a container with some liquid in it. Just get it done. Don't spend 10 minutes drawing.
Why?
You gotta learn. Drawing is not that important.
But if you see it.
Oof.
It's not that important here right now in this moment.
That's still offensive.
Yeah. Yeah. That wasn't
Eating.
nice.
And when I put my list of kids down at the desk in the near the main office, when you come for review classes, there's gonna be a band list. So we'll have a peaceful review class. I don't know why Amanda's laughing. I mean, she's gonna be on the band list.
That's why she's laughing.
All right.
Do you want to say you want like Cl, Na?
Yeah, everything. Yep. Just don't write inert
The
electrode.
equation on the bottom.
Yep, the equation on the bottom. Put them. So this half reaction here is going on at this electrode. This one's going on over here. That's why they're. So as you're drawing this, obviously, what's the big difference between the two cells? This has a battery. So when you're done drawing it, make sure you write underneath your drawing, all right, this is non-spontaneous. Non-spontaneous. And what that means is it needs a power source. Without a battery or some sort of electrical energy, electrolytic cells will not work. Okay? And so a voltaic cell produces electricity, an electrolytic cell uses electricity
Why?
to create chemical energy. It's the exact opposite of a voltaic cell.
Question.
Hold on one second. So it uses the battery, the electricity from the battery, to perform chemical reactions in the solution, which we're calling chemical energy. I put reaction in parentheses. Yeah, question.
On the equation at the bottom for Cl,
Yeah.
isn't 2Cl supposed to be a zero charge?
This is 0, yeah. Yeah, so this one's 0, and this one's 0. Because that's chlorine gas.
Oh.
This is this is
Okay.
positive 1 and negative 1. I'll explain that in
I
a
see.
minute.
Okay.
Yeah, I'll explain the picture here. Like I said, about in a minute. So yeah, for a Regents question, what do you need to be able to do? First, identify this is not voltaic, so it's the other one, electrolytic. The other thing is realize it needs a power source. That's a really common question. It'll ask essentially, what does this have, or what does this need? Voltaic cells don't need, or something to that effect. All right, it needs a battery. This doesn't have a salt bridge. Why? Because it only has one solution. It doesn't have two. Those are your three big differences. It has one solution, no salt bridge, and it has a battery. Really big difference. This is a completely different animal than voltaic cell. But the good news is everything you already learned you can apply to this. Anox red cat is the same. Fat cat is the same. Leo Gur is the same. Anions go to the anode. Cations go to the cathode, just like in voltaic. Everything you learn can be applied to this. These, what I wrote, these two things, that's really the big difference. of course, you've heard me say this a lot recently, but in AP Chem, we take this and it gets pretty hard. But in Regents Chem, this is it. That's all you need to know.
Oh, that's good.
You can take this information and do a whole bunch of math with it. That's what you do in AP. All right, can I erase this? I need a little bit more room here.
From the top to the bottom.
I can just leave it for a second. So, if the cathode is negative, so if you're done, stop writing. If you're not, then keep going, I guess. But I want you to look up here and pay attention. If the cathode is negative and the anode is positive, does it make sense the negative Cl is going to the anode and the positive Na is going to the cathode? Opposites attract. So yes, your head should be doing this. Yes, it makes sense. The positive Na, what it's doing here, it's at the cathode, so it's gaining, reducing, right? Anox red cat. So the Na plus is gaining electrons and jumping onto the bar and making more sodium. So sodium metal is going to build up on here. That's what's going to happen. Sodium metal is going to build, all right, on this bar, and that's why the fat cat. So it's the same principle. The cat ions are going to gain electrons and make more metal. Over here, it's the opposite. Okay, you're going to have Cl minus losing electrons, all right, and there's going to be bubbles over here because it's chlorine gas. This side is not quite as important. This is the side the Regis focuses on, with metals jumping on the bar. So again, there's not a lot to teach because you just learned it all with Voltaic cell. You just apply it to this. It's all the same acronyms. The only thing I do want to add, and then we'll go back and look at the Voltaic cell. Have you heard of this word? Electroplating.
I feel like
Raise your hand if you've heard of that.
maybe.
I feel like I should have.
I feel like Tristan would have heard of it. Thomas, you?
What do you put
All right.
together?
Does anybody have silverware at home? Steve, please sit up. Thank you. Like actual silver utensils?
Sure.
Okay, it's probably not pure silver. It could be, but I'd be surprised. It's probably silver plated. So what does that mean? Silver plated.
It's like not completely.
There's like it's like steel plated or covered with silver.
Yeah.
Okay, have you heard of gold plated or silver plated jewelry?
Okay.
Yeah. Or like, what about if you get some jewelry that's kind of cheapish, like it's gold, but it's cheap gold, it might leave your finger green or your
Yeah.
neck or whatever. That's because there's a lot of copper in it. But that's because well, there's a couple reasons, but where I'm going with this is it might be gold plated. And it's an alloy, so when it rubs off, you get that reaction. So what this actually means is what you're seeing right here. The cathode in an electrolytic cell will be plated with whatever metal ion you have in here. So let's write what this means. It's when a metal is plated on top of another metal. And they use electricity to do it. They use this. They use an electrolytic cell. So but industrial size. It's not like these little beakers and they have like a million of them. It's like these huge containers that you can, dip, I don't know, tons of metal at once. So when a metal is plated on top of another metal, so I'm just going to give you an example here. Draw another one of these things here. Okay, just sketch it quick.
Oh.
All right. Now, wait a second. Let's use a fork as an example. All right. So I'm gonna, instead of using this bar, I'm gonna draw a fork. This ought to be good. My fork's got a big handle here. There we go. It's more like a pitchfork or a trident. All right. I understand forks have 4 tines. All right. I knew they were called tines. I should just draw a spoon. That would be a lot easier. Anyways, this is how it would work. So you would put the fork, let's say it's steel, attached to the negative cathode, and then a solution. Well, if we want to plate it with silver, you need Ag plus ions floating around. So maybe you have like silver nitrate, AgNO3 solution, and then you dip the anode and cathode. So here's my anode, and then this is my cathode. Again, the cathode would be connected to the negative on the battery. And now, just like the picture, the positive silver would start to plate or jump onto the fork. So as long as the electricity is flowing, the silver ions will plate on the fork. Why? Because silver is getting oxidized and it's going from Ag plus to Ag0, which is solid silver. So when you reduce Ag plus, it plates as silver metal on the fork. Take the fork out, rinse it off, dry it off, and there you go. You have a silver fork, but it's just plated. But still, that's how it would work. All right. So that's a term you should know about electrolytic cells. All right. So I'm going to stop there. We're going to use the worksheets due tomorrow to kind of review this again and learn it a little bit more tomorrow. Let's go back and look at the Voltaic cell.